Hi, my name is Audrey Chen, and welcome to my Intel AI PC pilot project. You'll see how I changed a 67% accuracy model to over 80% with the Intel AI PC. So, the project is called DIATOS. A major problem is that 7.7 million people have diabetic retinopathy, according to Harvard Health. What if I could train a custom model to diagnose the stages of diabetic retinopathy? Well, I'll show you the demo of how it works, and then I'll show you what I did behind the scenes. You can see DIATOS is a multimodal LLM interface where you can ask a question and text, and also you saw the successful image upload and diagnosis of the stage of diabetic retinopathy. This is built for both health professionals and patients for more fast and accurate early stage diagnoses. The text model I'm interacting with is Quen 2.5 0.5 B Instruct, and the model I'll be training a custom model. So, in order to ensure a model that was fast and accurate, I decided to use the Intel AI PC's NPU, especially for pre-processing the data that I chose. I chose a pre-trained model, then a more specific model to be fine-tuned. And then it was time for the AI work. So, for the AI work, I started by using 6 unique components from the OpenVINO ecosystem. OpenVINO with PyTorch and TensorFlow. I installed Intel NPU acceleration, and then I used the toolkit in the GitHub repository for the LLM chat, and I adjusted the parameters. Although the demo looked simple, the processes behind were complex because of running processes on the NPU, real-time inference requirements, and the AI model evaluation and validation. I used OpenVINO's Optimum to export models, and then the OpenVINO toolkit to easily integrate a Gradio frontend with my choice of LLM. Now it was onto optimization. For the design and user experience, I started with the Gradio baseline, and I continued to iterate for 10 design iterations. That's why you can see this gorgeous front end that I ended up creating for the 10th iteration, with image upload interface, chat interface, and an about section for the user to understand. And here's the showcase of the Gradio code that added the glow and the color. Now the transfer learning model ended up taking 3 hours to train at the end, and it had started with a 67% accuracy and being refined 17 different times after. 10,000 epochs and an Atom optimizer later, I got an 80.22% accuracy for the final model. But will the test images classify correctly? Bam! Moderate was accurately classified in a medical website of the 4 different stages of diabetic retinopathy. And so it was the case of the proliferative case that was also diagnosed correctly. That's how we got to our clean demo at the final product. For the final impact, there would be an expected 30% increase in early stage diabetic retinopathy detection, inference computation and operational costs would reduce, and accuracy and precision would improve by 10%. With the accelerated development of Intel tools, I hope that tech is going to be used for good. I had a great time learning in the AI PC program, and I hope to keep learning with Intel.